Okay, so if you're not done, you can just try to follow me, but I hope everyone is done. Okay, so we do this because we want to kill this 5, right? So the second row, so 5 minus 1 is 0, okay, and then 10 minus, what is that? 5 times 3, 15, right? 10 minus 15, so you get minus 5, right? So if I do it incorrectly, or if it's not the same as your work, you can tell me. Maybe I'm bad at math. Okay, so 2 times 5 is 10, right? So 1 minus 10, so you get minus 9 here. Okay. So let's work out the last one. So 3, 2. You want to eliminate 2 here, so you minus 2R1, right? So this will be 0, and you 3 times 2, 6, right? 6, no 6, 6 minus 4 minus 6, so you get minus 10, and this is 2 minus 4, you get 2 times 2, 4, so you get minus 8 there. All right. And finally, you want to eliminate 10 here, right? So what do we need to do? To eliminate 10, you need to perform, you need to start with this, right? You have minus 5, and you want minus 5 to eliminate 10, so you say R3 is going to be equal to R3. If you multiply it by 2, and subtract it out, so minus 2R2. So you have to be careful. This is R1 and R1, so, but this is R2, right? So you get 1, 3, 2, the same thing, minus 3, minus 9, minus 5, minus 9, and then you multiply this minus 2, you get 10, add it up, you get 0. Okay. You multiply this by minus 2, you get, what you get? You get 18, right? And you add 18 to 8, minus 8, so you get 10 here. Okay, so this is what you get. Okay, same thing. Okay, now let's figure out the elementary matrix. So here we take R2, 1 unit of R2, and minus 5 units of R1. So you put minus 5 here and 1 here. And here you take 1 unit of R3 and minus 2 units of that. So you get minus 2 over there. And here you have 1 and minus 2 over there. Okay, so you should get all this. Okay? So these are the results, and these are the elementary matrix. Okay? Now, we'll try to combine them somehow. Okay? But before we do that, let me make a quick remark. Okay? The final matrix is upper triangular. We usually refer to this matrix as U, upper triangular U. Okay? But the elementary matrix, okay, they are also triangular, but the non-zero variable, the non-zero numbers are on the lower part of the triangle, right? So this matrix will be combined somehow to get to the matrix that we would refer to as a lower triangular matrix that we refer to as L, and then we get LU decomposition. So that's the name. Okay, let's try to combine them now. Okay, so let me save it for now. Okay, so let's get back to our example. So this is different matrix now, but we have the same kind of thing. Okay, so these are the results that we have, and these are the elementary matrix. Okay, we start from matrix A. Okay, we start from A. Start from A, and we multiply to get to this matrix. Okay, from A to this matrix, we multiply A with this one. Okay, so this matrix, okay, is basically A times E12. Okay, you get this matrix. Okay, how can you get to this matrix? You multiply this with E13, right? So this matrix is E13 times this one. But this one, what exactly this one? This one is E12A. Okay? And to get to this matrix, what do we need to do? We multiply this matrix with E23, right? So this matrix is basically E23 times E13 times E12 times A. And this matrix is U. So we get this equations. Okay? So basically, you do 3 row operations. We do that by multiplying A with some elementary matrix. Okay? To get to this matrix. Okay? This is what we just did. Okay? Okay? If you write them down, let's look at that. In the slide, I call the matrix U by B, but I have already spoiled U, so I call it U. But yeah, let's call it B for now. Okay, so this left-hand side matrix is B, and this is the starting matrix that we have, and some of these are the elementary matrix that we do to get to that matrix. Okay, but our goal is, we would like to write them. We would like to factor matrix A. We would like to write down A into some simpler form matrix. Okay, so but right now we don't get what we have, we don't get what we want. So we want to write A to be our goal. Okay, we want to write A to be something times something. Okay, but now I only get A times something, and then I get B, right? But currently, if I look carefully, matrix B is a nice matrix because it's a triangular matrix. Okay, but I don't get the form of the form of the equation that I like. Okay, how can we get to that form? Okay, what we do next? Is basically we want to get rid of this guy. We want to get rid of that guy. How can we get rid of that guy? Okay, let's have an analogy. Okay, I have something called x, right? And I have 4 times 5 times 6 times x equals some numbers. Okay, I want to basically get back to x equals something, this thing times something else here. What should this thing be? To do that, I can just, if I have real numbers, I can just divide the whole thing by 4, right? And then I divide the whole thing by 5, and then I divide the whole thing by 6, and I get x, right? So we can do that quickly by doing this. So I multiply it with, dividing by 4 is basically multiplied 1 over 4, right? 1/4, and then I get 1/4 here, and then this guy cancel. Okay, I would like to cube 5, so I multiply with 1 over 5, so I get 1 over 5 there, and then I multiply with 1 over 6, get 1 over 6 there. And this guy cancel, and that guy cancel, and then I get x equals some of this. Okay, that's real numbers. Okay, but somehow you can do that with matrix C as well. Okay, so the idea is that we would like, let's do it one step at a time. Okay, currently we have E23 times E13 times E12A equals B, right? I would like to find a matrix C. Okay, I want to multiply the whole thing by C on the left hand side. Matrix, when you do matrix multiplications, they are not commute. Okay, they are not commutative. So AB typically is not going to be equal to BA. Okay, but when I multiply the same matrix with the same matrix on the left hand side, I can do both. Okay. What I would like to do is that I would like to find matrix C. If I multiply the whole equation by C on the left hand side, somehow this matrix C is nice. 2, 3, right? I multiply with C, and this one sort of cancel out. Okay? When I cancel out, it goes to what should the matrix be when, so this cancel out to 1, right? So when matrix cancel out, what would you like to get? What is the row of 1 when you do multiplication? So you multiply anything with 1, you get the same thing back. Okay, it's an identity. Okay, it's the multiplicative identities. For matrices, do you have matrix that act like that? Multiply it with something and you get the same thing back. You get identity, right? So you want to find a matrix C such that you multiply C with E23 and you get the identity back. Okay? What is this matrix? Let's have a name first. The matrix C has a name. Okay? It's the inverse of E21, E23. Okay? So when you have a matrix A, so I have a slide here. So I teach backward. So identity, the identity matrix are the one where you have 1 on the diagonal and 0 everywhere else. So you have 1, and these are 0, 0. Okay. And some matrix has an inverse. So if an inverse of A is matrix that multiply with A, you get the identity back. So if A is n by n matrix, the inverse of A denoted by A to the minus 1, okay, is a matrix that multiply with A, you get the identity back. And you can think of it as if you have a matrix AB and you multiply A on the right hand side, on the left hand side, this one cancel out, get back to I, and then you get B back. Okay? This thinking algebraically, that's how it works. But if you think of the matrix of what we just did, okay, what does this matrix do? So we want matrix C to be in such a way that whatever E23 did to your matrix, matrix C would bring it back. Okay? What do we mean by bring it back? It's like you multiply something with the matrix. That matrix changed the original matrix that you have, right? And you want some matrix, another matrix that multiply it and then bring it back to the same thing. Okay? So if you think about this, you have, so let me say this. So suppose you have a matrix B, a matrix A, right? And you multiply A with B. So basically you start with A, but B bring you to somewhere, right? You want some matrix that we refer to inverse of B to bring it back to A, right? So this matrix sort of like bring you back to the matrix that you start. This is the inverse. Okay? When you think about the inverse, you think about algebra and operations, but basically inverse is like, as the name said, you did something and you undo it. Okay? It's like control C. Okay? Now let's look at this way. This E23, what does it do? It basically say R3. It perform row operation, right? It say R3 equals R3 in this matrix. So R3 equal R3 minus 2R2, right? Okay. What should the inverse do to get everything back? So the inverse would basically add R3 with 2R2, right? This matrix doesn't do anything much. It basically subtract the third row with 2 times the second row. Okay, so its inverse would be basically add the third row with 2 times the second row. Okay, so that's the inverse. So it's easy. So okay, so these are the elementary matrix that we have, right? มันต้องเขียนสลับนะครับแป๊บนึงนะครับ อันนี้ E32 E12 okay, so this matrix, right? So it say R3 equals R3 minus 2R2, So its inverse, what is its inverse? Its inverse usually do R3 equals R3 plus 2 R2, right? So that's the inverse, look like this. So you basically change the sign here, okay? And what is the inverse of E13? 1 0 0 0 1 0 3 0 1. And finally, what is the inverse? So it's 1 0 0 2 1 0. Okay, so that's the inverse. After we get this inverse, we can multiply everything and we get what we have, what we would like to have. Okay, and then I multiply the whole thing with the inverse. But if you need to be careful on the ordering, okay? So the last matrix that you multiply is E23. So you need to multiply the inverse of E23 first, so that this guy cancel out, and then multiply with inverse, that's inverse and that inverse, right? And you get A back, and you get this matrix on this side. And if you multiply all the inverse of the elementary matrix together, okay, if you multiply all this together, it will be easy. You actually do the multiplications, okay, you get this. If you multiply them, okay, this is like take 2 from that, take 3 from that, and then you just basically copy all the thing and you get this. Okay, then you finally get this starting matrix A equal LU. So this is lower triangular matrix. This is the upper triangular matrix. What you did is what we call the LU decompositions. Okay? Which is really helpful when you want to do some things. Okay? So this is how we express the Gaussian elimination as matrix multiplication, and it gives us some properties like this. Okay? So let's try to work on that in the exercise before we head back to the building รีบทำเลยครับจะได้เดี๋ยวต้องเดินทางกลับสู่มาตุภูมิ Okay, so the third, okay, let's fill out the inverse here. So the inverse. Okay, so inverse of E12 is gonna be 1 0 0. So you subtract 5, right? So you add 5 back. Inverse of this is gonna be 1 0 0 1 0. You add it back. Finally, inverse ของนี้ก็จะเป็นit's like that. Okay, after you get all the matrices, okay, the last few steps is just write them down. Okay, so if you follow this, if you write all the matrices, you can skip step C. Okay, can skip step C. Okay. Call this matrix U. Okay. So to get this, you need to write U times all these matrix. So you multiply them back, right? So you don't have to write them down, but let me write them down so that you know what we are doing. Okay. So we have matrix A. I don't write what inside the matrix, okay? And then you multiply it with E12, right? And then you multiply E13, and then E23, right? Equals B, equals U, right? And then you multiply the whole thing with inverse of this, inverse of this, inverse of that, and then you get A back. So you get A. Okay, and this is the matrix U that you have. Write U down, and then you multiply with E23 first, right? So it's gonna look like E23. Okay, and then you multiply with E13, which is this one, and finally this is gonna be this one, and then this is A. This is U that you have. Okay. Now you multiply them all this, then you get A equals, if you multiply this, which is basically just copy out, and you get matrix U. This is the LU decomposition that we talk about, okay? And then this is it. If you get to this point, you can bring your work, you can submit your work and be done for today, okay? And then we'll go back to our building together, or maybe you can just walk, okay, to the 5th floor. So write them down, and then you get to what is U. So I don't remember what is U. 132 ลบ5ลบ90. Okay, so this is the LU decomposition that we keep talking about. So this is U, this is L. Okay, okay. There will be, today we have a homework posted on Classroom, Google Classroom, which basically asks you to do this.